of Momentum and Collisions, and today we are going to see what is elastic collision, what is inelastic collision, and also collisions in 2D. And collisions are a part of our day-to-day life, and there are so many events, so many phenomena which can be explained with the conservation of momentum principle and the theory that you're going to learn today. So welcome, this is Shreyas here, your physics master teacher at Vedantu, going live for all of you. And this series, which is the nurture series, is meant for all the JEE 2023 aspirants. But by chance, if you are a 2022 aspirant and if your 11th standard syllabus is not so clear, you're still welcome to this session. Hello Kara, hello Saja, hello Ritik, Selvan, Ankit, yes, that's billiards bacha. Hello Panamian Silvai, hello Sar says Panamian, wow, such a nice long name. I hope I'm getting it right. Hello Harita, good evening. Chandan, Zayad, nice to see you back again. Good evening, thank you for all the hearts, says Preet, and all the students out there. Hello Payal, sir, how to value time? The way to value time is to basically burn your fingers and realize what you lose when you waste time. So, I mean, that's, you know, when you you learn a lesson when you actually suffer from it, and you should ask the value of time to a dropper. You should ask the value of time to a athlete who misses his, you know, Olympic medal by few seconds. So if you want to know the value of time, you should probably ask all those students who have lost something or who have, you know, missed an opportunity because they did not value time, and then probably you will get motivated to actually, you know, utilize the time that you have, Ankit. Hello Suchi, good evening. I hope you guys are doing well. And Remo, okay, so Remo is a beautiful short name. I'll call you Remo. Hi Rosni, thank you for all the love. Yep, I know that 32 minutes ago I was live. And before we go ahead to the session, I hope all those new warriors who are here today know what this channel is about. This is for all the engineering aspirants who want to learn in English, and we are going to prepare you for QVPY, for JEE, for mains, advanced, and all the other entrance tests that you need. And if you have hit the subscribe button, also hit the like button, so that, you know, it helps me gather that motivation when I see you guys are loving these lectures. So yes, please go ahead and hit that like button. Now, some of you might be there who have some questions about, you know, the CBSE examination, or want to prepare for the CBSE board examination, that is even in the 11th school examinations, you want to do well, and some of you might be actually having some backlogs and a lot of doubts, and you want more mock tests. Let me tell you, Vedantu also has a CBSE crash course, a CBSE long-term course for all of you. Well, there was actually a CBSE long-term batch which started back in June and July, but in case you missed it, we also have batches which have just started now, and this will complete your entire syllabus. Not just that, you will also have quizzes during the class, because remember that CBSE examination is now MCQ based, and you can also watch the replays, and you will also get the notes, and you will also get your doubts cleared within the doubt app and even during the class using our 2-teacher model. And there are lots of micro courses for each and every topic and for each and every type of problem. Let's say you want only numericals, there is a micro course for numericals, for, you know, case study based numericals, and so many other things. And all these micro courses along with our regular crash course will help you get really good results even in your school examinations. So if you're interested in that, please go ahead, check out the link in the description box below. The course, which was priced at 10,000 rupees, is usually off at 5,000. Now, using my coupon code, which is SHHPRO, this is a universal coupon code. This will give you discounts for all the courses, not just CBSE, but even 12th, or even the long term, or even the pro courses, whatever courses. You can use that, you can save a lot of money, like you can see over here. So use this and you will get this course for 2,700 rupees only. Let's start with what is the different type of collisions that we encounter in day-to-day life. Okay, so Akash, I'll definitely give you some tips. You can do one thing, can you leave a message after the video ends, or probably ping me on Instagram, I'll definitely help you out, okay? Thank you Saja for all the love. And yep, let's not forget to check out our last time's homework, and yeah, I always give homework towards the end of the class, and you need to solve it and post it up in the comment section below. So this was our class which was conducted yesterday. That was me, and you can see some of you have started posting the answers. Very good, Ishpreet, you are very regular. Very good, Chandan, glad you enjoyed it. Anil always enjoys the session and learned a lot. Okay, on resistor, yes, I'll definitely consider it. Geeta, Harita, loved the session. Thank you, Gokulnath. Well, yeah, Vaishal had a test on collision and I'm pretty sure it helped him. Okay, and paper attempting strategy, I just conducted a session for KVPY Jayan. You can watch that. Okay, so please check out my KVPY strategy session. You can just search for it on YouTube. Shreyas sir KVPY strategy, you'll get it. Can I skip theory? I already replied. Thank you for all the lovely comments, and please post your homework so that I feel that okay, whatever I'm teaching you are understanding, and plus that's the only way you will be systematic in the studies. So make sure you post up all the answers which I give it, the answers to all the questions which I give it to you as homework. Okay. When will the Pathfinder series complete, Aviram? I will start the term 2 syllabus in December, and by January it will be complete, much before your March attempt of CBSE or even JEE Mains. Okay, 3 months before. Oh, no problem, Sajab. Maybe you can put it tomorrow. Okay, let's have a look at the different types of collision. Now, you might have heard about rubber band. There is a special property about rubber band. What is that special property? When you stretch it, it elongates, and when you leave it, it comes back. Sponge, when you press it, it compresses, leave it, it comes back. Spring, you stretch or compress it, leave it, it comes back. These kind of objects which come back to their original position, they are called as elastic objects. But those objects which do not come back to their original position, example, cheese. You might have all had those lovely pizzas, okay, or burgers, and you put cheese over them. And when you take out that pizza slice, you know, the cheese elongates. But when you leave the cheese, it does not come back. It stays there. It becomes more elongated. Or you might have burnt a plastic pen or mug or some plastic object. You burn it and you will see that plastic flowing, or you know, plastic threads coming out. And when you stretch that plastic, you leave it, it stays there. So that is plastic or inelastic behavior, where when you deform the body and leave it, it does not come back to its original shape or size. Now, based on this, you categorize the collisions on whether it is elastic or inelastic collision. Now see, what happens during a collision, both the bodies which are colliding with each other, they have some kinetic energy. Now, when they hit each other, just imagine you and your friend. Okay, just imagine you and your friend. Maybe let's take the example of Pandu. This is Pandu. This is poor Pandu. Okay, very, very thin. And this is Golu. And what is this Golu and Pandu doing? They are moving towards each other. Now, imagine they have kinetic energy and they hit each other. They collide with each other. Now, there are multiple things that can happen. Let's say they are made of elastic bodies. So when they hit each other, their bodies compress. This Pandu gets absorbed inside Golu. Golu is fat and Golu absorbs Pandu. The stomach compresses. And then what happens? It will be deformed, but remember, the deformation won't stay for long. Golu will leave back that Pandu. So Pandu is going back, Golu is also going back, and they are back to their original shape, size, everything. So this kind of collision is very elastic in nature. So this is elastic collision, and the reason is both the bodies regained back their original shape, size, everything. There was no loss. There was no energy which was absorbed. There was no bonds which were broken. There was no heat which was produced. There was no sound which came. There was no light or sparks. Nothing. No drama. So no drama collision. This is elastic collision. The energy is retained. I hope this is clear. Similarly, imagine another example where Pandu keeps running. He collides with Golu. Golu's teeth comes off. Phat karke. Pandu collides with Golu, one teeth of Golu comes out, tuck karke. Then Golu's one hand breaks, he becomes fractured. Okay, and Pandu also gets fractured, his leg gets fractured, his nose gets cut, his nose starts bleeding, random. And once they go back after collision, they're all like deformed. One hand is broken, one's leg is broken, one nose is bleeding, one teeth is fallen out somewhere. So bonds broken, deformation, sound, they're screaming their lungs out, light, sparks, all the drama that you can think of. So this is inelastic collision. You will see some energy is lost. That's what will happen. Thank you Bachaluk for all the love from Kerala, Tamil Nadu and all the parts of the country. So the point over here is, in different types of collision you will see either the energy is not lost or the energy is lost. So that's why you get elastic and inelastic collision. So in elastic collision, which is perfectly elastic, you will see that there is no loss of energy. So like a ball bouncing endlessly. Look at this. From the time I have been talking, this ball has been bouncing. Did you see that? There was no energy lost. It's just bouncing. There is no energy lost. So this is an elastic collision. Yep, correct. Similarly, what is inelastic collision? Look at this. Tuck, 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 tuck. Tuck, 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 tuck. Gone. That energy is gone. Every collision, some sound, some heat, some light, some deformation, some particles are thrown out. So it is continuously losing energy. So that is inelastic collision. In an inelastic collision, where there is a loss of kinetic energy, although the momentum might be conserved. So maybe the momentum is conserved, but kinetic energy is definitely not going to be conserved. And the example is of a ball which gradually stops after some bounces. Yes, energy is lost. Hello Swarlina, long time. Well, Anil loved the explanation. Yep. So shot hit by a batsman, looks like Zayed is fond of cricket. And yes, so when you hit the cricket ball, or when you hit any ball using the bat, or maybe you can just hit it with your hand or anything else. So remember, most of the collisions which happen around you are inelastic in nature. Why? When you hit the ball with the bat, there is some sound which is created. You might see some particles of the bat just fly off. Correct? That bat might get deformed. So some energy is lost. So hence, most of the real world examples are elastic collisions. When you have rubber-like bodies or spring-like bodies, and when they collide, those collisions are elastic in nature. Guess what? There is a third type of collision. Can you guess what is the third type of collision? Yep, the third type of collision is perfectly inelastic collision. Just imagine this, okay? Just imagine this. It's a very good example that I can think of. Imagine this is Pandu, and Pandu has a chewing gum. Okay, has a chewing gum, and this is beautiful Champa. Okay, now Champa is skating on ice. She's probably skating on ice like this. Okay, Champa is skating on ice, and what is happening now is Pandu looks at Champa. Please don't do that in reality. He takes the chewing gum, he gathers some 7-8 chewing gums, gathers it, makes it like a ball, and aims at Champa and throws it on Champa. So he takes the chewing gum and throws it on Champa. It sticks to Champa's hair. Okay, it sticks to Champa's hair. That's it, it gets stuck. Champa becomes angry. She takes that stick and throws it at Pandu later on. Okay, a lot of violence. Let's not go there. So this kind of collision, what has happened? The colliding objects, in this case the chewing gum and Champa, they got deformed, that got stuck. There was some energy lost, but they did not separate. It got stuck, they moved together. So that kind of collision is a perfectly inelastic. Maximum energy will be lost. That's what is the perfectly inelastic collision. The bodies get stuck, they move together, maximum energy is lost. Like a ball which is dropped and comes to a halt, it does not even bounce back. There is no hope of coming back. It just gets stuck to that surface. It just stops over there. All the energy is lost. Maximum energy is lost in a perfectly inelastic collision. So what are the different types of collisions, my warriors? Elastic, energy is conserved. Inelastic, energy is not conserved. In inelastic, you have perfectly inelastic, where maximum energy is lost and the bodies move together or stick together. Okay, let's start solving some questions based on this. Very interesting question coming up on your screen, and here it is. You have a marble and there are 3 more marbles on a smooth floor. This marble goes and hits the second marble. What do you think will be the speeds eventually if it's a perfectly elastic collision finally? Chandan is clear. Alright. Sir, how momentum is conserved? Dharun Balaji, 1, 2, B, 3, 0, 4. Here is the logic. See, momentum is conserved if there is no net external force. Now, in different collisions, what happens is if there is no force from outside, the collision force is internal, momentum has to be conserved. Yeah, energy may be lost, energy might be conserved. That's a totally different story. So even in inelastic collision, momentum is conserved if net force is 0. I hope that makes sense, Dharun Balaji. Okay, now in order to solve this problem, let me prove something to you. Imagine you have a ball of mass m which is traveling with speed u, and it collides with another identical ball which is right now at rest. After the collision, what happens is this ball moves with speed v1 and the other ball moves with speed v2. Can I find this v1 and v2? I think so. Let's try this out. Because this is elastic collision between identical balls and energy should be conserved. So here are the equations that I can think of. First is momentum. Initial momentum will be m into u. It is at rest. So 0 is equal to m into v1 plus m into v2. M goes. So u will be v1 plus v2. This is one set of equations. Second set is energy conservation. Initial energy is half m u square. Final energy is half m v1 square plus half m v2 square. Why are they equal? Because it is given to be elastic. Half m goes. So u square will be v1 square plus v2 square. But wait a minute, u is v1 plus v2, correct? So how about putting it over here? So when I put that, I'll get v1 plus v2 whole square is v1 square plus v2 square. Open this up. A plus b whole square is a square plus b square plus 2ab. So it will be v1 square plus v2 square plus 2v1 v2 is equal to v1 square plus v2 square. v1 square v2 square, v1 square v2 square cancels out. So what I am left with is just 2v1 v2 is 0. Now when the product of two numbers is 0, then either v1 is 0 or v2 is 0. Now which one do you think is 0? Come on my warriors, think about it. Answer this question. Is velocity of 1 0 or velocity of 2 0? Only one of them will be 0. Think carefully. If this is 0, that means this is at rest and this is moving. So after this collides, this ball stays there and the other ball goes ahead. That's this option. The second option says v2 is 0. That means this ball collided and this ball stayed at rest. How can this move? Think about it. The first ball collided with the second ball. The second ball stays at rest. First ball is still moving. How can it move? How can it pass through it? So hence, this is wrong. This is correct. This is wrong. This is correct. Yes, v2 is 0 is the wrong solution. v1 will be 0. So what happens is when the balls collide, the first ball stops and the second ball moves ahead, assuming both of them have the same mass. So in an elastic collision, you'll always see for identical masses the velocities get exchanged. If this has some velocity, it will give this mass that velocity. That's what happens. The velocities get transferred to each other. Correct. It should cover a little distance at least, yes, but that distance is dx to g. We ignore that distance because the time of collision is in microseconds or in milliseconds. So remember this property. In elastic collisions, in elastic collisions between identical masses, the velocities get exchanged. Very, very important property. This is not just true for rest and moving, it is always true for anything that you have. The velocities get exchanged. So having said that, now you know what will happen over here. See, think about it. P1's velocity will go to P2. P2's velocity will go to P3, P3's velocity will go to P4. Eventually only P4 will move and rest, all of them will be at rest. And that's why the correct answer is C. Done, done. Got it? So that's the logic behind it. Remember this very important property. Okay, so we just solved it. Answer is 0002, option C. Moving on to the next question. Sir, but for heavy M2 will it work? No, Dharun Balaji, like I said, this property only works for identical masses. Otherwise, you have to solve it using equations. You will see that we can get equations as or we want. Okay, so we have a body of mass 20 grams moving with speed of 2. It collides with another body moving with in the opposite direction with the speed of 4. Okay, same mass. Now the collision is perfectly inelastic. Then what do you think will happen? The bodies will interchange their speeds. Will the two bodies combine and move with a common speed of 2? The two bodies combine and move with a common speed of 5.2. The two bodies combine and move with a common speed of 1. Interesting question. Okay, some of you are saying option B. Cholan says B. I don't know. Let's figure this out. First, remember, always draw the diagram. Last lecture I had given you some steps. So there is this mass of 20 gram. It is moving with the speed of 2 meters per second. And there is identical mass, and that is moving at a speed of 4 meters per second. Interesting. After that, they become one single mass of 40 grams. This speed is more, this speed is less. So obviously, net speed will be this way, which I assume it to be V. Fair enough. So if I take this direction to be positive, because I know eventually everything is moving towards the left side, what will be my momentum equation? M into V. 20 into 2 plus, no, minus 20 into 4 is, sorry, my bad. This was negative, this was positive. So this is negative. So minus 20 grams into 2 plus 20 grams into 4 is equal to 40 grams into V. Grams will get cancelled everywhere, so you don't even have to worry about it. So 20 into 4, 80. 20 into 2, 40. 80 minus 40, that's 40 again. So 40 is equal to 40 into V. So therefore V is equal to 1 meter per second. So basically the final answer is D. That means this mass which is moving slowly, this mass which is moving fast, after they combine, they move this side with the speed of 1 meter per second. That's what it is. KSA friends, you should go with Tattva module, which Vedantu gives. It has all kinds of questions for mains and lots of practice with theory, formulas, important definitions and tricks. And the second book is obviously HC Verma apart from NCRT. Okay, chalo. That's option D. I hope you guys got it. Moving on to the next one. Some of you said B. Oops, B is not the correct answer, but chalo. Okay, let's have a look at the next one. Come on, let's do this. And what is the next question? We have a particle of mass M and it is moving with speed 3v. It collides with another particle of mass 2m moving with speed v in the same direction. Draw it and think, if it is perfectly inelastic collision, then what do you think will be the loss in the kinetic energy? So why that equation is used? Suchivama, remember I had mentioned a line in inelastic collision. Even if energy is lost, the momentum is conserved. So I do not know how much energy was lost. So that's why I used momentum conservation equation, because that will be always valid when net force is 0. Okay, Suchi, let's solve this question. The first step is to draw it. And even if you feel that you cannot solve it, it's okay. You can write it with me and that will give you that confidence. Okay, first let's draw. Particle of mass m moving with speed 3v. Okay, so this is a particle of mass m moving with speed 3v. Okay, collides with another particle 2m moving with v. The mass is 2m and the speed is v. This is before, and there is perfectly inelastic collision. Okay, so mass m 2m. Okay, so the final mass will be obviously 3m and the new speed will be v1. Okay, the question is, what is the loss in the energy of the system? In order to find the loss in the energy, I know the initial mass and the speed. I know the final mass, but I don't know the final speed. Unless I know the final speed, how can I find the loss in the kinetic energy? Make sense? So what we need to find? First find V1. How do we find V1? Obviously conserve momentum. So conserve momentum and see what do you get, because momentum is conserved no matter what. So initial momentum will be, think about it, m into 3v plus 2m into v is equal to 3m v1. 3mv plus 2mv is 5mv is equal to 3m v1. So v1 will be 5v by 3. So I have found out the final speed. So that will obviously now lead me to loss in the energy. Okay, let's see how to solve this. And KSA friends, if you have doubt in work per energy, please let me know in the comments after the video ends if you have any specific doubt, or if you don't have clarity on that chapter, please watch my Nurture series playlist for work per energy. I have explained work per energy principles, problems, so many concepts in 4 to 5 classes. Please watch that. Okay, let's see what do we do. So the loss in the kinetic energy will be whatever kinetic energy is there initially minus the final one. Why initial minus final? Because I know the loss will be calculated by higher minus the lower value. Initially there was more, something was lost, so remaining will be less. So final is less. So higher minus smaller number. So it will be half into m into 3v square plus half into 2m into v square minus final energy half into 3m into v1. v1 is 5v by 3 whole square. Let's see what do we get. mv square, mv square, mv square is common everywhere. So mv square common. 3 square is 9. So 9 by 2 plus 2 gets cancelled. So plus 1 and then minus. We have 3 by 2 into 5 square is 25. 3 square is 9. 3 and 9 goes. This will become 3. Interesting. So 2 into 3 is 6. So this will become 9 by 2 plus 1 minus 25 by 6. That's what I get. So taking further LCM. LCM is 6. So 9 into 3 will be 27 plus 6 minus 25. The whole thing divided by 6. So this will become 27 minus 25 is 2. 2 plus 6 is nothing but 8. So it will become 8 by 6. 8 by 6 is nothing but 4 by 3. So hence it will become mv square into 4 by 3. Do we have such an option? Yes, it is there. I think somebody told it also before this. Okay. Very good, Suchi. You were able to solve. Very good, Cholan. Very good. I think Roshni. Yes, correct. Very good, Divya. Very good, Chandan. Excellent, Anil. Very good, Harita. You guys have got it finally. So you understood the idea now. Loss in the energy, if it is asked, find the final speed using conservation of momentum. Sometimes you might be given the energy and you might be asked something else. So it depends what is the problem. But the idea should be clear. In inelastic collision or elastic collision, momentum is always conserved. Okay. Having said this, let's move on to the next question coming up. But I think there might be, yes, a theory. Yep. So the next concept is, sometimes what if it is not a perfectly inelastic collision? Or what if it is elastic collision also, and you might need one more equation and you don't have energy information with you. I'll give an example. Just imagine there are two bodies like this, m1, m2, they are colliding. Before colliding, these were the speeds. After colliding, these were the speeds. So if you had to conserve momentum, so by conservation of momentum, what will you get? Initial momentum will be m1 v1. This will be minus m2 v2, because it's opposite, is equal to final momentum. This will be minus m1 v1 prime. That is going that side. So plus m2 v2 prime. Now usually what will be given? m1 will be given, m2 will be given. v1 initial speed and initial speed will be given. What you wouldn't know is v1 prime and v2 prime. Do you see how many variables or unknowns are there and how many equations are there? Think about it. Yeah, no KSA friends, that's where you have gone wrong. No formula. If you remember the formula for v1 prime and v2 prime, they are not teaching you physics. You are just remembering formulas. Don't just remember formulas, you should know the method. And the formula is very big and it might be given to you in your schools or I don't know, random coaching, and they just fool people. I mean, it's not needed. In the history of JEE or BITSAT or CET or anywhere else, you would never use such a big formula. Go by logic. Within 2 equations you will get the answer. You can clearly see you have one equation and 2 unknowns. That means you need one more equation to solve it. And that equation comes from Newton's law of restitution. Yup, Newton gave this. Hello Maruf, welcome. Newton gave this formula. He said for a pair of bodies which are colliding, if you calculate the relative speeds of colliding or approaching each other and relative speeds of going away from each other, that ratio remains constant. He found out that the speed of separation, actually this should be relative, so relative speed of separation upon relative speed of approach, they both have a fixed ratio for a given pair of bodies, and that ratio is called as E. What is that E? Coefficient of restitution. You'll be like, sir, I don't know E, sir. Do I have to buy at it? No. That will be given to you in some or the other way. Okay. So the value of E is like coefficient of friction. It will be given to you. It is an experimental value. So that will be given to you. So based on that, you can solve the equations. Let's say for this scenario, if I had to write down one more equation, so E will be, think, relative speed of separation. This mass is going that way, that mass is going that way. If you sit on one mass and look at the other mass, you will see they are going away from each other. So the speed of separation will be V1 prime plus V2 prime. That's the speed of separation. It's like 2 cars, 2 bikes going away. So this speed and that speed will get added, correct? And divided by speed of approach before the collision. So this guy is moving with V1, this guy is moving with speed V2. So if they are coming towards each other, what is the speed relative to each other? Again, it will be V1 plus V2. That's it. Now I have 2 equations, 2 unknowns. I can solve it to get the answer. Is that now clear? With respect to what? Very good, Arun. With respect to each other. So you sit on one mass and look at the other. Relative with respect to each other. So relative with respect to each other. Remember that. So you sit on this. What is the speed of the other guy? I hope this is clear. Exactly, Cholan. Because they are in opposite directions. That's why the speeds will add. Hello, Jacob Mont. Think about it. This was taught back in relative motion. I have been doing this problem again and again. So every time I've seen so many students, every time, sir, I don't know when they add, I don't know when they subtract. Please watch my relative anti-motion class, it will be clear. That's the basics of physics. If you do not know that, you will face a lot of trouble ahead. So please watch my lecture 1 of relative motion 1D. It's all there in the playlist. Remember, when 2 things with respect to the same frame approach or go away, the speeds will add. When they are moving the same direction, then their speeds will subtract. If the speeds given are with respect to the same frame of reference. Is that okay? Great. Sir, is this E which is in the maths? No, Chandan, this is coefficient of restitution. That E which you get in logarithms or exponents is a completely different E. Okay, that's Euler constant, that's different. Okay, this E will be, okay, let me tell you. For elastic collision, guess what the value of E is? And for inelastic collision, guess what the value of E is? And for perfectly inelastic collision, guess what the value of E is? Well, no brainer. Think, for elastic collision, the speed with which they approach and the speed with which they go away will be the same because no energy is lost. So E is 1. No energy loss. But for perfectly inelastic, they approach but they don't separate because they stick. The speed of separation will be 0. They hit each other, get stuck, they move together. There is no separation. So this numerator is 0. That means E will be 0. For everything else, this value of E will be less than 1 and it will be more than 0. That's what will happen. Is that clear, bacha log? Is that understood? Clearo? Let me know by giving a thumbs up and yes, smashing the like button down there. Okay. Okay, Saja, I'm not going to write 3-4 pages derivation because I always like to keep physics simple and you should always feel physics. You should always understand the concept behind it rather than just mugging things up. Sir, do one shot for work, energy and power. Divya, I would love to do one shot for work, energy and power. But tell me one thing, Divya, you are in 11th standard. Why are you getting into one shots? Because one shot is like steroids. It's like drugs. It is like, very bad for a student who is in a long-term batch and whose target is JEE 2022 or 23. When your exam is so far away, see all the lectures properly, bacha. You don't need that right now. You need that medicine. If you have not studied for the last 2 years and just the exam is 3 months away, and then I will do one shot. But yes, having said that, I will do revision classes. I'll do problem solving classes on work, power, energy and so many other things which I have already done. That way is fine. But studying from one shot is a big no-no for you guys, especially in 11th standard. Do not do that. It will spoil you. You will never understand anything. It is very bad. Yes, very true, Chandan. Yeah. I know I will get more views if I do one shots, but I will not do that. Okay. So probably I might get less views because I will conduct all these lectures separately 1, 2, 3, 4 and I will explain everything, but that's okay. I'm okay with low views as long as you understand it properly. Okay, that's what I'm here for. I'm not here for just views. Okay, so let's get going with the question coming up on your screen. Is there term 1 examination for class 11? Yes, Karthik, that will be your school examination, not a board examination. Okay, look at this. There is a steel sphere and it is moving, and the question is, if the mass is 100 grams moving with a speed of 2 meters per second and it collides with a dust particle elastically which is moving in the same direction with a velocity of 1 meter per second, and the velocity of the dust particle after the collision is how much? Okay, let's draw the diagram. It's an elastic collision. Yeah. Here is what we have. So first of all, we have a steel sphere of mass 100 gram. With what speed is it moving? It is moving with 2 meters per second. It collides with a dust particle. Okay, this is dust particle. Dust particle means very less mass, little mass, negligible mass, same direction with a speed of 1 meter per second. The speed of the dust particle after the collision is. Many of you will start writing the equations, but I'll tell you where you will fail. The part where you will fail is you do not know the mass of the dust particle. Okay, Gagandeep saying B. Okay, let's see how to solve this question. See, it's clearly mentioned that it is elastic collision. And in case of an elastic collision, E is 1. That means relative speed okay, of separation upon relative speed of approach, that is 1. Okay, that's what elastic collision is. Now, okay, think this way. After the collision, what is going to happen? This was before, right? This was before. After the collision, what do you think will happen? This is 100 grams. It's like 0.1 kg. Dust particle is like milligrams. It's very small. Will the speed of that steel sphere change? Obviously not. It's very heavy as compared to the dust particle. So it will continue with almost the same speed. But the dust particle, when it gets hit, it will move with a new speed. Let's say I call it V. See if this is understood. Now just use this equation and see what do you get. Relative speed of separation. Dust, after the collision, the dust will move faster. Dust particle will move faster as compared to the steel sphere. So what is the relative speed between them? It will be V minus 2. Make sense, my warriors? V minus 2. What is the speed of approach between them? This is moving with 2, this is moving with 1. What is the relative speed before the collision? It is 2 minus 1, this is 1. So V minus 2 2 minus 1 is 1 is equal to 1. So V minus 2 is equal to 1. So V is equal to 3 meters per second. And that's the answer, option B. Done, done, are done. That's how you solve these questions. So you will find these kind of questions in mains. You will find these questions in BitSat and CETs and so many other places. So remember, speed of separation is speed of approach for elastic collisions. Draw the situation before and after. Mark the speeds, and if your concept of relative motion is clear, you will be able to easily solve the question. Option B is correct. Moving on to the next one coming up on your screen. Yep, done, done, done. Very good. Let's solve this question. There is a ball, and what is it doing? It is moving with a certain speed. It collides with another body of the same mass at rest. Coefficient of restitution is half. What is the speed ratio of A and B after the collision? Okay, so what's happening? Let's draw it before first. So there is a ball A of certain mass. It collides with another body of the same mass. This is ball A. This is speed U. This is another mass. This is ball B, but that is at rest. Many of you will be like, sir, I know what happens. Speeds will get exchanged. Wrong. It will not get exchanged. Why will it not get exchanged? Read this. It is half restitution. Okay, it's half restitution. Okay, Sajja, I don't know how you saw the answer, bacha. Okay, great, great. I don't know. Is there some magic? Is there some ghost? How you are seeing the answers? Oh, all right. Anyways, so after the collision, the speed of this guy is V1, and the speed of this guy is, let's say, V2. So the question is, find V1 by V2. So let's just find V1 and V2. As simple as that. Okay, first thing, let's conserve momentum. So conserving momentum, let's see, what do we get? Initial momentum is m into u plus 0 is equal to m into v1 plus m into v2. Therefore, u is equal to v1 plus v2. That's one equation. Another equation that I can use is restitution, because it is given. Remember, what did I tell you? Restitution will always be given to you, and then since it is half, it is 0.5, that means it is an inelastic collision. So half will be speed of separation. Look at this. When they collide, they go like this. So these two masses collide, they go like that. So you can see B is moving faster than A. So when A collides with this will go like that. So higher minus lower speed. They both are moving like this. V1. So this is V1, this is V2. So the relative speed between them will be V2 minus V1. Make sense? Okay, that's the numerator. Denominator is always approach. Approach speed, that's easy. This is at rest, this is coming with speed U. So it will be just U. Okay. Now let's just simplify this and see what do we get. U will be equal to 2V2 minus 2V1. Interesting. Let's say if I call this as equation 2. Let me do one thing. Let me take this equation and multiply it by 2 and see what do we get. So I'll get 2U is equal to 2V1 plus 2V2. This I call it as equation 1. Why did I do this? Because if I add 1 and 2, 2V1 and 2V1 will cancel. So adding equation 1 and 2, what do I get? 2U plus U. 2U plus U is equal to 2V1, 2V1 gone, 2V2, 2V2 plus 2V2. So this will be 3U is equal to 4V2. Therefore, V2 will be 3U by 4. Interesting. The moment I get the value of V2, I think I can also find V1. So from this equation, okay, from this equation, I know U is equal to V1 plus V2, which is 3U by 4. Therefore, V1 will be U minus 3U by 4, which is U by 4. So that's V1. Once I get V1 and V2, I think I can find the ratio. So V1 by V2 will be U by 4 divided by 3U by 4. U, 4 gets cancelled. So 1 by 3, which is option B. Done, done, are done. Oh, no problem, Gokulnath. All the best for your test. Oh, is it? Okay. Okay. I think the answer was there before, is it? Okay. I'll just have a look. Maybe usually the answer should be there afterwards. but I'm not sure if the answer was shown before. Okay, so that's the answer, option B. What is the previous? Oh, this was the answer for the previous one, B. Oh, looks like we have all B's today. All the options are B's. Okay. When will I start revision for class 12th first board? Akhila, after your KVPY SX examination. Okay, Akhila, I have already completed one-shot revisions for your term 1 examination. Revision series I had done it for Gauss's law, electricity, capacitors, and even magnetism, the initial part. So the remaining parts I will complete it, and you will also have more problem solving sessions and term 1 sessions and also preparatory sessions for your term 1 examination and the first part of the syllabus from the point of view of JEE as well. Okay, so that was 1:3. Moving on to the next question. Okay, Anil, you guys have understood it. Beautiful question. You drop a ball, tuck, bounces, less height, bounces, even less height, bounces, less height. So every time it bounces, the height reduces. The question is, what is the height till which it bounces after n amounts? Let's start the question. Okay, h naught is the initial height. Okay, so this is basically your h naught. Okay, this is your h naught. Let's say this one over here is h1 and so on and so forth. I mean, like this will be, let's say, h2, and this will continue, and eventually after n bounces, this will be hn. Okay, this is n bounces. h0, h1, h2, h3, h4, hn, continued. Now, when this ball falls down, it hits the ground. Okay, it hits the ground with velocity v0. It hits the ground with velocity v0. But since it is an inelastic collision, E is given. So E is given, that means inelastic collision. So it will rebound with a slightly lesser speed. So let's say that new speed will be v1. So after it hits, it goes up, it starts going up with a new speed v1. It goes up till height h1, stops, comes back. Obviously, it will also again hit back with the same speed v1. Makes sense? Whatever speed it is thrown up, it will come back and hit with the same speed. But after hitting, the speed will reverse and it will become less. Is this point clear? When it hits, the speed is v0. When it rebounds, the speed is less. It goes up, comes back with the same new speed, but after it hits again, the speed is reduced further. It will now become, let's say, v2, goes up, comes down, again hits it with speed v2. The same thing continues even for the nth velocity. This will be vn, and this will again come down by vn. That's what happens. I'll tell you what. In order to find hn, I think I just need to find vn. Yep. Trust me, that's all you need to find. How? This is 1D projectile. So 1D vertical motion. In 1D vertical motion, what did I tell you? The height reached by that object is the speed with which it is thrown. So Vn square divided by 2g. That's all. So all you need to know is what is Vn. Done, done. If you know Vn, you get the answer. Now how do you find V1? That's very easy. So for the first collision, think about it. For the first collision, if you write the equation of restitution, here is how it will look like. E will be between which two surfaces? The ball and the ground. Approach, separation. Approach is V0. Separation is V1. So strictly speaking, it should be V1 by V0. This is separation. This is approach. Everybody agrees to this? Everybody agrees to this? So therefore, V1 will be E times of V0. Okay. Now, for the second collision, similarly, think this ball goes up, comes down. Second collision. Approach and separation. What will E be equal to? Approach is V1, separation is V2. It hits with V1, separates with V2. So it will be V2 divided by V1. So V2 will be V1 into E. But wait a minute, V1 is E into V0. So it will be E into V0 into E. So it will be V0 into E square. Interesting. V1 is E into V0. V2 is V0 into E square. Naturally, think what V3 will be. V2 is V0 into E raised to 2. So V3 will be V0 into E raised to 3. V4 will be V0 into E raised to 4. This will continue. So Vn will be V0 into E raised to n. Think about it. That's it. I have got whatever I needed. So Vn is V0 into E raised to n. So this will be V0 square into E raised to 2n divided by 2g. That's the answer. Oh my god, Swati, what made you miss all my classes? KSA friends, what do I explain again? After everything you are asking me to explain again, which part you did not understand, let me know. Okay, so, yep, great. So that's the way to solve this. The idea behind this question is every time it hits, the speed reduces. V0 becomes V1. V1 comes back, reduces to V2. Goes up, comes down, V2. V2 reduces to V3. V4, V5, Vn. So I understood to find the height after the nth collision, I need to know the nth speed. And by projectile motion formula, height is initial speed square by 2g. So I just need to find Vn. How do I find Vn? You find a trend. For the first collision, you can see separation between the ball and the ground is V1. Approach is V0. So V1 by V0 is this one. So you got V1. Similarly, you get V2. Now from this and this, from just this and this, you found out a trend. What is the trend? For V1, it was nothing but E raised to 1 V0. For V2, it is V0 into E raised to 2. So you got the trend and that's it. Put it over here and you get the answer. Yep. Is it okay, KSA friends? I hope you have understood it. And still, if you're not got any point, you can definitely watch the replay. Oh, I forgot to put up H0. So I think I had to substitute the value of H0 again. Yeah, because we got the value as V0 square and E raised to 2n divided by 2g. Let me tell you, this value over here, this is nothing but H0. Yep. Why is that H0? That's very obvious. If it was released from H0, the speed with which it hits the ground will be root of 2g H0. Squaring both sides, this is standard formula. V0 square will be 2g H0. So V0 square by 2g is H0. That's, you can, you know it. Yeah. Yep. So Vignesh, how about this? Leave a comment after the video and I'll definitely recommend you all the books, okay? Or you can still ping me on my Instagram handle, I'll definitely help you. And let me tell you, if you have any doubts while solving the questions, or if you do not understand a solution, or if you are facing difficulties in solving problems, do not search on the internet. In fact, use our doubt app, because we have doubt experts with whom you can chat and get all your doubts and answers clarified. Make use of this fully because it's available for all the subjects, all the days from morning till evening, free of cost for all our Pro Classic and Pro Plus users. Now let's move on to oblique collisions, collisions at an angle. Here is what it is. See, till now, whatever collisions have happened, all of them have happened in 1D. This ball comes, hits it, it goes like this. This ball is at rest, it goes like this. You never saw a collision which was something like this. A ball collides another ball, they go at an angle. Let's solve these kind of questions. You'll be wondering, sir, what is the special knowledge that we need to have for solving oblique? Oblique means at an angle, or collisions in 2D. What do you think the answer is? What is that extra knowledge you need for solving these problems? The answer is you don't need anything. Yep, correct, Chandan. Carom is a good example. Pool is a good example. Football colliding with another ball. Most of the examples are collisions in 2D. A cricket bat hits a ball, the ball deflects at an angle. Collision in 2D. Kaju Kashyap. Yes, Kaju Kashyap. Oh my god. Please don't keep such names. I get very tempted and I start thinking about Kaju Katli. Yep, you're a little bit late, but it's okay. You can still continue and watch the replay of the missed part. I'm available, Akhila, on pro subscription. In fact, a lot of my micro courses are there. You can watch all those problem solving, HC Verma, derivation, so many things on pro subscription. I'm still there. Okay, I'm always there. So the idea is you don't need anything. You don't need anything for solving collisions in 2D, because whatever you have learned is still applicable in 2D. Just that you have to resolve the vectors. That's all. So for example, if something collides with something and they move at different angles, all you need to do is make sure you use vector resolution and collisions in 2D. That means you need to probably conserve the momentum in 2 directions. In 2 directions. Yep. Remember, yes, Harita, very good. It is nothing but 2 1D motions. Exactly. So you can conserve the momentum in one direction, conserve the momentum in other direction along suitable directions. You can also conserve energy if needed. Let's say it is elastic collision, then use energy conservation. But let's say it is inelastic collision, then you cannot use kinetic energy conservation. What will you do? You will use restitution coefficient. Yep, restitution coefficient. Ankit, you can join my batch in a very simple manner. I'll tell you how. Just leave a comment after the video ends. I'll ping you the link and the instructions to join it. Okay. It's not my long-term batch, but those are my micro courses. You can join it. I'll just leave a comment. I'll ping you the instructions. Okay, say, how would I know what Wasim sir is going to teach, bacha? I should ask Wasim sir, no? How will I know? Okay, great. Akhila, that's what. I'm not teaching in the long-term batches, because if I teach in the long-term batches, then what will happen? Because I'm teaching on YouTube, then my availability will not be there for the special courses. That's why I conduct very special courses, because these courses I know what to do, like Urodo course, derivation course, problem solving course. These are my specialities. I have been teaching for a very long time, and we have very good teachers right now, you know, for the long-term batches. For these special courses, this is where you will need my guidance. That's where I will be there. Is that okay? And Divya, my next session for for 2023 will be tomorrow for KVPY SA. So the 11th standard KVPY SA. Okay. Now, the idea is when you use the coefficient of restitution equation, keep this in mind. You have to use the equation along the line of impulse. Very, very important. See, in 1D it was simple. But in 2D, what is that relative velocity that you will take? Relative velocity along which direction? That direction along which the collision is happening. Like, sir, along what direction is the collision happening? See, it's simple. If there are 2 bodies, they collide, okay, they collide like this. After some time, they hit like this. This body will apply an impulse this way. This body will apply an impulse this way. When you extend this line, this is called as line of impulse. Line of impulse. And along this line, you take the components of the velocity. So if this object has some velocity here, you take the component of this velocity along this line, and that's what is very crucial. So don't worry, if you feel that it's very difficult, we'll solve some questions so that you get a hang of it. Let's take this question. So there is a ball, it hits a surface which is inelastic at an angle of incidence I, rebounds at a different angle R. The question is, what is the relationship between I and R? Now, many of you might think, sir, I is equal to R, sir. I know this optics. Angle of incidence is equal to angle of reflection. That's not true when the collision is inelastic. And this is why probably you're not so good at carom or pool. Many of you think, sir, I know, I have played carom, sir. Rebound shot. I hit it like this. I know the angles will be same. No. In fact, these angles are different. I will prove that to you. We are going to solve some equations. Let's see what do we need to do. Let's assume that initial velocity, okay, let's say this initial velocity, okay, it is u, and I can split that velocity into 2 components. You can see that because this angle is I, naturally this angle is also I, and this component will be u cos I, and this will be u sin I. I hope that makes sense. After it hits and rebounds, then this angle over here is R, so it has some velocity this way, Let's say I call it V. Why is it V? Because inelastic. That means some energy is lost. So speed won't remain the same. Great. This velocity, again I resolve it into two components. If this is R, naturally this will be also R. You can see that. This will be also R. This will be V cos R. This will be V sin R. Very good. When this ball hits the surface will exert an impulse when it hits it, and that impulse will be along this direction. Okay, so this is basically your line of impulse. Does that make sense? Think about it. When this body hits the surface, there is a contact. So there is a contact force. So that force will create an impulse. So the line of impulse is along this line. Makes sense? Great. Okay. Now, okay. Let's see what do we do next. Let's probably conserve momentum. Now you'll be like, sir, where do I conserve momentum? How do I, and whose momentum do I conserve? See, line of impulse is along the direction of the contact force. Now, here is what I will say. For the ball, the net force in the x direction is 0. Because when the ball hits the surface, the force is in the y direction. Is there any force in the x direction? No, right? If there is no force in the x direction, conserve momentum. Momentum in x is conserved. Does that make sense to you? If there is no force, there is no change in momentum in that direction. Yep. So, okay, friends, I have completed it all in the playlist. It's all there. What about friction? Kamalnath, we are ignoring the friction. Okay. So, I think that word smooth was missing, but yes, this is a smooth floor. If it is a floor with friction, then it becomes very difficult. We need to know mu, you need to know the time of collision and so many other things. Okay, Kamalnath? Well, so let's assume this surface to be smooth. So if it is conserved, what is the momentum in the x direction? M into u sine I. So m into u sine of I is equal to final momentum m into v sine r. Okay, so m into v sine r. mm goes, so u sine I is equal to v sine of r. This is my first equation. Everybody got it till here? Okay. What is the next thing? I have not made use of E. Let's make use of E. E is separation upon approach along the impulse. Very, very important. So relative speed of separation upon approach along the impulse. Let's see what it is. Along the impulse, what is the speed of separation between the ball and the surface? I know the ball is going like this, but it has two components. Along the impulse, what is the velocity of separation? Surface does not move. The ball moves with the speed of v cos r. So v cos r will be speed of separation. And approach along the impulse, that means this direction, that's u cos I. So this will be u cos I. So take this over here. So you will get E into u cos I is equal to v cos r. This is equation number 2. Think what will you do? You are going to look at equation 1 and equation 2. What are you going to do? You do not need u, you do not need v. You don't need them. You just have to find relationship between angle of incidence and angle of reflection. So eliminate that by taking first equation and dividing it with the second equation. See what do you get? U sine I divided by E u cos I is equal to v sine r divided by v cos r. V goes, sine by cos is tan. So tan I by E is equal to sine by cos again tan of r. So tan of I by tan of r is equal to E. This is our final answer. Done. That's it. So clearly you can see I is not equal to R. Only if E is equal to 1, I will be equal to R. If E not equal to 1, I is not equal to R. You can clearly see that from this equation. Make sense, my warriors? So next time you play carom, remember this: angle of incidence will not be equal to angle of reflection. Yep. Very, very important. And remember this rule. This reminds me of Snell's law somehow. In Snell's law, optics, you have sin I by sin R is refractive index. Here, tan I by tan R is coefficient of restitution. Beautiful question. Moving on to the next question on oblique collisions. Collisions at an angle. Collisions in 2D. Here is the next one. After a perfectly inelastic collision between two identical particles moving with the same speed in different directions, the speed of the particles become half the initial speed. What is the angle between the velocities before the collision? Draw it, only then you will get it. If you do not draw it, you will be confused. Think. After perfectly inelastic collision between two identical particles moving with different directions. So this is a particle, mass m, let's say it goes like this with some speed u. This is another particle, mass m, same speed u, different directions. They come, hit each other. After they hit, because it is perfectly inelastic, they become a mass 2m. Interesting. Now, if you draw a line like this, this is angle theta, this is angle theta. They collide, stick. After sticking, where do you think they will go? Will they continue on the x-axis? Will they have some component in the y-axis? What do you warriors say? Come on, my warriors. Think about it. Oh, my minion, you are a little bit late. In fact, quite late. And I like that smiley. That face is very evil, and that cry and that laughter together. I mean, it looks very cool. Yeah. Okay. Option A says Anil Kumar. Let's figure this out. First of all, think about it. Will there be any momentum in the y-axis? No, right? Yeah. So obviously it will not be there, because when they collide symmetrically, there is nothing that will be left out in the y direction. So after the collision, what you will see is they both of them, because of symmetry, move like this. They move like this, only in x, correct. And this will be u by 2. Why u by 2? It's given. It becomes half the initial speed. It's given. So what do we do next? Conserve momentum. Let's do this. So conserve momentum. And many of you are wrong, by the way. Many of you have written down the answers and they are all wrong. Let's do this. So initial momentum, in which direction will you conserve? X direction. Why? Because that's where everything is moving almost. In X direction. Momentum of this guy in X direction. Think about it. This component will be u cos theta. Because if this is theta, this is theta. If this is u, this will be obviously u cos theta. Why? Because this is theta. Y components ignore. So mu cos theta plus mu cos theta. Why 2 times? Because there are two masses moving in x direction. Is equal to final mass 2m, final velocity v. So this will become 2mu cos theta is equal to 2m, v is u by 2. Okay, a lot of things are going to get cancelled. M gone, u gone, 2 gone. So I am just left with cos theta is equal to half. So theta is equal to 60 degrees. This is where many students make a mistake. What is that mistake? Now I think when I told that option A is wrong, you guys realized it. Whatever you get may not be the final answer. See what is asked. Angle between the velocities. That means 2 theta is asked. Hence the answer is 120 degrees. Correct, Divya. Correct. It is not 60 degrees. So which part you did not understand, please let me know. The idea is that when they collide, the momentum will be conserved in x and y. But there is nothing that I will get by conserving it in y-axis. What will I get? Nothing is happening in the y-axis. So I conserved it in the x. And when this velocity is is like this, and this is theta. Remember, this is also theta. So this will be u cos theta. And obviously this will be u sin theta. I am only interested in the x direction. So I have used mu cos theta of this mass, mu cos theta of this mass. is final momentum because the stick, it's perfectly inelastic. 2m into final velocity, and it was given final velocity is u by 2. That's it. Yep. Is that clear? Now, Sunny Hemon, yes, you're late, very late, but it's okay. Watch it, and maybe watch the replay later on. Is that understood? Clear, Suchi? Okay, very good, bacha. Now let's solve the best question for today. Are you warriors ready? Hello, Siddhartha Kunibli, superb. You will say more superb in the next question because this next question is even more superb. Oh my God, Anushka Bele, you are in class 9th. There is something with me and class 9 student. You know, I'll tell you one thing. I'll tell you one secret. Should I tell you one secret? I don't know. You know, in my history of teaching, all the students, by the way, this time Pune is topper, Pune city topper, because I had taught him in 8th, 9th standard. He is right now the JEE Advanced Pune topper. Last year, JEE Advanced topper, again my student from Pune. Okay, I had taught him in 8th, 9th, 10th. In fact, some bit of 11th also. So, I don't know, it always works. This year's Bangalore city topper, okay, again, my student, JEE Advanced. So, I don't know, somehow, you know, students who have been studying and associated with me from 9th and 10th, they have done exceptionally well and they have become really great toppers. And I really hope that this association continues and you guys top it whenever you write it in 2024, 2025, 2026, 2027 or whenever. Let's solve this question. Read it, see what is asked. The question is you have to prove something. And what is it that you have to prove? You have to prove that an oblique elastic collision between two particles where one of them is at rest, the motion is perpendicular to each other after the collision. Thank you, Anushka. Thank you, it means a lot. Thank you. Chandan is from Mysore. All right. We have a lot of people from different parts of the country. Great. And that's what I want to do. I mean, I really want to spread this joy of learning in each and every part. I don't want to be limited to one city. The whole of India should benefit. Whole of India should prosper. The whole of country, as kids, should do well. That's what I want. And let's make this family bigger. And thank you very much for making this family more than 75,000 subscribers. The next goal is 1 lakh. Let's make it fast. Let's make this bigger, my warriors. Okay? Chalo, let's do this. Show that during oblique elastic collision between two particles, one of them is at rest. Okay, this is the mass. This is moving with some speed. Oblique collision, that means they are not hitting against each other head on. One is at a distance or at an angle. So this mass is at rest. After the collision, this is like your pool or carom. It's like cut shot. This hits, they go like that. So one mass hits the other mass, they go like this. So this mass goes here and this mass goes here. The question is to prove that these velocities are perpendicular. Let's do this. I'm glad to know that, Harita. Build that confidence, and I hope this motivation always stays with you, Harita, and stays till the end. I really will be waiting for that day to celebrate with all of you. Now, I will use a brilliant technique. Many of you might not be expecting that technique. In many books, I have seen this solution. It runs into pages. What they do is this. They split this velocity into two components. They assume the angles are alpha, beta. This is alpha, this is beta, because I don't know what the angles are. I have to prove that it is 90. Then they conserve the momentum in this direction, conserve the momentum in that direction, use coefficient of restitution along the line of impulse, and then you get three crazy, scary looking equations. Solve them with all the sines, cos, tans, etc. Solving it, finally you will be able to prove it. That's what you need to do if you use the traditional method. But you are attending Shreyas sir's class. We should learn different approaches. And let's see what will be the unconventional way, but very interesting way of solving the problem, which might help you in some other problem. You never know. First thing, I know momentum is conserved. Okay. Momentum is conserved. How about this? Use the vector equation of momentum. Every time we use scalar equation, let's use vector equation. So m u bar plus 0, because it is at rest, is equal to m v1 bar plus m v2 bar. Advantage of writing this equation, I don't have to split. When I write it as u bar, v1 bar, v2 bar, it already means I cap, j cap notation. I have not explicitly written it down, something I cap, something j cap. I don't care, I just written it down. Okay, KSA friends, you should solve many problems on your own, only then your speed will improve. Solve many questions on your own, that's the only way. M gets cancelled. So therefore u bar will be v1 bar plus v2 bar. This is equation 1. Now, since it is given it is elastic collision, that means energy is also conserved. Energy is conserved. So when energy is conserved, let's write it down. Initial energy will be half mu square. Final energy will be half m v1 square plus half m v2 square. Half m cancels. Therefore, u square will be v1 square plus v2 square. Are you able to see that, my warriors? U square is v1 square plus v2 square. Interesting. Now comes the best part about this problem. Anushka, my next class will be tomorrow for 11th standard kids. That will be a KVPY essay class. And then usually my timing is 7:30 or 5:30. 7:30 usually I will be there, but sometimes at 5:32 and sometimes at random times. So better to hit the bell icon so that you get notified, and also join the Telegram group to check out the timetable daily. U vector is v1 vector plus v2 vector. So if I show v1 vector and v2 vector, the resultant of that is u vector by triangle law of vector addition. By triangle law of vector addition. Yes, KSA friends, E is 1. But remember that I have, instead of using E is equal to 1, I have used energy equation, one and the same thing. Okay. Yes, Sarsi, you are a little bit late, but it's okay. Watch this problem. It's very interesting. Now, look at this triangle and look at this equation. Look at this triangle, v1, v2, u, and look at this equation. This says u square is v1 square plus v2 square. This is only possible in one situation. Pythagoras. This is Pythagoras. One side square is second side square plus third side square. This is converse of Pythagoras. If one side square is second side square plus the third side square, then the two sides should be exactly this. I have drawn it as obtuse, it doesn't matter. This should be 90 degrees, and hence proved. I like writing this, hence proved. Look at the beauty of the solution, where there is hardly any complexity in the solution. The elegance of this solution lies in writing it in the vector form and skipping E is equal to 1 and making use of energy conservation. Such a killer, beautiful, amazing problem. I hope you enjoyed this. Isn't it amazing? Go. I hope it is clear in all your minds. Very good. Now this is your first homework question, my warriors. Please post it up in the comment section. I will be reading out all those names who are going to do the homework. This is your second homework question. Drop a comment below. This is your third homework question. These are your daily dose of assignments that you get so that you understand my class. And where will you get the solution? You will get it on the Telegram channel link, which is again there in the description box below. So if you're watching this video right now, and if you're interested to join my courses, if you want all my micro courses, and you want to join the CBSE plus JEE long-term batches plus the crash courses, all you need to do is click on this. There are specific courses, but the big one that you should join. See, imagine like this. You want to watch only movies? Amazon Movies. You want to watch only series? Okay. You want to listen to only music? You join some streaming service for music. You want only books? You join another service for just books. So these are these things. If you just want CBSE Term 1 crash course, that's there. 11th and 12th science, that's there. You want everything, then click on JEE 2 years. That's it, you will get everything. You get even the CBSE preparation done for all of you, and you not only get live classes but also the recordings of them. You also get the test series with the analysis, beautiful report cards with the timings and all the beautiful charts that you would ever require. Assignments with again all those basic data analysis that you would need, and it's all online. You can reattempt it again and again and keep a track of your scores. Doubt solving during the class because we have a 2-teacher model, and doubt solving on the mobile app because a lot of you will have a lot of doubts after the class, and that's available in the classic version. Okay, and if you want some personal guidance, then you go for the plus version over here. The cost is slightly different for each one of them. Most students go for the classic version because they want the doubts. Some students also go for the plus version when you need a mentorship. Now, this price is 60,000 for the classic. For the light version, it's 53,999. That's, hardly 3,000 rupees a month when you go with an EMI option. But there is a beautiful offer running for all of you. And what's that beautiful offer? You can try this course for 15 days. And you get this course only for 1,350 when you use my coupon code SHHPRO. But that's not the best part. You get additional 15 days free. So you get a 30-day trial for 15 days price at a discount of more 10%. So that's amazing offer for all of you. This is very limited offer. Try it out. It was 15 plus 15 days with 10% discount. That's the best deal that you can get. Alright, so I'll be looking forward to see all of you in this crash courses and the long-term courses, and plus they are available in English. That's the best thing for all of you. And if you enjoyed today's session, please hit that like button, show your Guru Dakshina there, share it with your friends, recommend this channel to your friends, and also hit the subscribe button so that you do not miss any of my classes. Yeah, Chandan, this is better than Tata Skybox. You have interaction, you have guidance. It's a two-way Tata Skybox. Thank you, Roshni. Glad KSA friends. I hope you enjoyed the session and you understood it. And I hope I clarified all your doubts. Bye-bye, Harita. Bye-bye, Anil. Take care. Take care, Chandan. My minion too. Take care. Sir, what micro courses am I taking presently? My live micro courses are not there now, but all my micro courses which I conducted in the last month are still there as a recorded format. When I start my new micro courses next month, those will be available for you. Okay? Bye bye, Srishti. Take care. Hasta la vista. See you tomorrow.